So far, we've tried to talk about programming languages as generically as possible. So in this lesson, we'll talk in particular to the Python language and give a short overview of its features. So Python is a very high-level language. It means that you have access to a lot of functions that are already implemented in the core language. For instance, if you have a lot of different objects and you want to sort them according to some order, there is very efficient sorting algorithms that are already implemented in Python. Or if you have a lot of objects and you want to retrieve a specific one, that also is optimized. Many things have been implemented and are available to you immediately. It's also general purpose, as opposed to very specific purposes like some languages have. So it's not specific. For instance, it's not designed to be a computer algebra system. It's not designed to implement a computer algebra system, but it's very well suited for it. It's suited for a lot of things actually, and that is what makes Python great. The language is extremely modular, so a lot of it works by importing what is called modules, so adding functionality by bringing in new libraries. And the core language is very simple, but a lot of libraries are available for it. So this means that if you're writing a program to a computer algebra system, you might need some modules, but not some others. And you are not bothered by the fact that all those other modules are available, you just don't use them. So just to give you a range of applications of Python that are possible, the platform we're using now called edX is also written in Python mostly. So you see that it can be used for very different things. You could never write something like this platform in Mathematica, or you would have a really hard time. A lot of Python is used in modern tools that we use every day. So Google, a lot of it is written in Python. Dropbox, for instance, a lot of it is written in Python, things like this. So every language has its own emphasis, and for Python, the emphasis is maybe unexpected. It's on humans. Python tried to emphasize the readability of code. So it really values code that you can just look at and understand immediately. That's what makes its syntax look very similar to mathematics as well. So you can write things that are very mathematical looking, and the main reason I suspect is that mathematicians have developed their notation also to be easily understandable. So that's why there is this convergence. And finally, in a related note, so to emphasize readability of code, indentation is important. So the fact that indentation is important is something that's often taken as a negative for Python. You don't use curly braces, for instance. You don't use extra symbols except spaces to symbolize indentation, to symbolize structure, to symbolize blocks. Use indentation. So if you want to highlight a particular block in Python, you'll have some code, and then suddenly you'll decide to indent it, and that's the notation I'll be using for indentation, and you indent it like this, and then you go on. And this selects this particular chunk as a block. Now, you have to be very careful with the spacing, though, because you have two ways, essentially, of writing spaces. The first one is using tab, and the second one is using the actual space that I'll symbolize like this. So this would be 4 spaces. Now, depending on the editor and depending on who you're working with, if you're sharing text files, if you're sharing Python source, the tabs sometimes get expanded into spaces automatically, which is actually a good thing, except that it's not always the case, and it's not always the same number of spaces, and generally the treatment of tabs is inconsistent between the different operating systems. So it's better in general to always use 4 spaces. So that's really the recommended way, and try to avoid using tabs. That's a bad idea. And certainly don't mix the two. Now, if you're going to use 4 spaces, you might tell me, but this is going to be boring. Each time I want to write a new line, I'll have to add another space. Well, it depends on your editor, and some editors can be set up so that you only use, whenever you type tab, it's expanded into 4 spaces. Okay, so that's for a general overview. Now, different versions of Python exist, starting at version 1 in 1994, version 2 in 2000, and version 3 was released in 2008 and was really an evolution of 2.0, or the 2.5 that was at the time. But the problem is that it broke backward compatibility with version 2 point something. So 3.0 and later 3 point something versions are incompatible with 2 point something. It's a slight incompatibility, but still it's annoying. So it's just annoying because your code that works for Python 2.x will not work for Python 3.x right away. But it's simple enough that for a human it makes no difference. It's just as easily readable. You know right away how to change it. You can even program something to switch from Python code 2.x to Python code 3.x. That exists. It's called 223. That's the name of the program. Anyway, after that came further developments of Python 2 that actually included some of the features of Python 3, and this evolved finally into Python 2.7, released in 2010. So this is the version for the course. And you should always make sure that this is the version you're using, otherwise you will get in trouble. For instance, the print statement is a bit different in 2.7 from 3.x versions. Python was created by Guido van Rossum, and he was working at Google until recently, and now he's at Dropbox. And he has consistently stated that both of those companies, and in general many of the modern companies of Web 2.0, use Python, and that he was surprised by how much they used Python. So let's try to talk about the different aspects or the different programming paradigms that Python is trying to push. So as I said earlier, the main aspect is imperative, but it also supports some functional programming aspects and some object-oriented aspects. Actually, both to a large extent. But we'll talk right now mostly about the imperative aspects, so you know a bit what we'll see in the course and how it might be structured. So remember, in the von Neumann architecture, we have some data, we act on the data, and then we always have to decide what the next operation, what the next instruction will be. So we have some kind of flow control. So those are the three different parts that I want to highlight. And for the data structures, there is a lot of data structures that are built in. Of course, you can build more, but the standard data structures that you will have are hints, ints, floats, strings, tuples, dicts, lists as well, of course, and a few others. So ints would be for integers, float for floating point, arithmetic, so real numbers essentially, or maybe complex. Strings are for strings of characters, and the later ones are a bit more complicated. Okay, so what kind of actions can you do? Well, you can evaluate expressions, or you can execute statements, and you can also package those actions into reusable actions, and you will have what's called functions and procedures. So in general, the word functions is used for Python. We don't really use the word procedures, but we'll still see it a little bit. Now for the flow control, well, you can use conditionals, so you can use if, you can use loops, and this will be done with for and while. You can use generators and iterators, which is a great feature in Python and very, very relevant for mathematicians. And finally, you can use exceptions as well. We'll see a bit of that. And there are a few other methods, but they are maybe not as mainstream. So one of them would be short circuiting, which is great, but maybe not the first thing to see. Now I want to introduce you to some vocabulary that's relevant to Python. So some of it we've already used, but let's make it a little bit more formal. So we'll have programs or scripts, which are sequences of definitions and commands. The definitions will be evaluated and the commands executed, and all this will happen in what's called the Python shell. Now, a command, also called a statement, tells the interpreter to do something. So this is an example of a command. The command is to print this string on the screen. in general, Python can also manipulate objects. So that's what it does all the time. And each of these objects has a type. So everything is an object in Python, which is a very good thing. And each of those objects has a type. For instance, the simple types, what's called the built-in types, would be an int, a bool, a float, a string, or a dict, and so on. Now you can combine different objects with operators to form expressions. And these expressions themselves have a value, and this value is itself an object. Okay, so you can combine several objects together using operators, and what you get are expressions, and these expressions can be evaluated to a value. What can you do with those values that are objects? Well, you can associate them to variables. So variables will associate a name with a given object, and this operation is called it's done via an assignment, and this whole concept is called binding. So this is very important, the word binding. So variables bind to objects in Python. Try to remember that. Now, the names of those variables, they matter for humans, but they don't really matter for the Python shell itself. Well, the shell only uses the names to identify specific variables. So you can't have two variables with the same name, that's for sure. But beyond that, the shell does not care about the name. It doesn't try to extract information from that name. So this means you really, the names are really free for you as a human to choose, and you should choose them carefully, because you're trying to sometimes convey information with the variable names. So don't choose variable names that are extremely short, just 1 or 2 characters, unless you precisely you are sure that the meaning of that variable is completely explicit from the code itself, right? So if you have one variable that's radius, consider not using R, but explicitly writing the variable name radius. Now, how do you know what are the allowable variable names? Well, you can use any character, upper and lower case, and Python makes a difference between the two. You can also use digits, but not as a starting in the starting position. So you could have letters and then some digits, and you can use also underscore, and the underscore is generally reserved to separate different words. So if you want to have a variable name composed of two words, you would separate it with an underscore. So you could have H person. That would be a variable name that is allowed. So as I said, variable names are case sensitive in Python. Python makes a distinction between upper and lower case. So this variable name would be different from this one, for instance. Okay, and there's also a lot of reserved keywords. So meaning keywords that you should really not use because Python has a different meaning already built in for them. Okay, so this is words to really avoid as variable names. And in order to know which, you can take a Python shell, type import keyword, which imports some functionality from another module. And this module keyword has in particular a list of keywords that you access through this way. And you will see a list of all the keywords that are known. Now, most of them you would not use immediately, you would not use naturally, except maybe for or if. Those are two of the keywords. Return is another one. So those have a specific meaning in Python. One that you might use in a math context is lambda. So stay away from lambda if you can. And well, you have to actually, as a variable name, it's useful as a reserved keyword, but as a variable name, you're not allowed to use lambda. And otherwise, look at the list yourself. Now, this is an example little Python program that actually works in the shell. And we see here some part that I didn't talk about at all. And this is a comment. And it's indicated to Python that it's a comment thanks to this hash mark here. So everything that follows a hash mark is just ignored by Python. Okay, so for Python development, as I said, there is the shell, and that comes standard with every distribution of Python. So if you're running on Unix or on Mac or on Windows, you will have the shell. That's the way you interact with Python. But another one that comes with every Python distribution is called IDLE. So it's an integrated development environment coming for Python. So basically, it's a text editor, a shell with syntax highlighting, so it recognizes the keywords and highlights them. And there's also a debugger that's integrated. And it's not just any text editor, it will also do syntax highlighting, it will do autocompletion and smart indentation. So smart indentation means that if you are within a block, so you have started to write some code here, and then you've decided to start a block and you press return, then your cursor will not start here again like you would in Word or something, but it will start here. So Python will expect that you are continuing the same code block, and each time you press enter, you end up here. So it helps you with keeping the indentation. So this should be available on any platform, but even more friendly than IDLE is what's called IPython, but this is less portable. So this is an interpreter. IDLE can also be used as a shell. Okay, so this was for a general overview of Python, maybe a little bit of how to interact with Python. And now we'll go a little bit deeper into the first constructs of the language.